Well, hello there and welcome to this little tutorial guide on unified sampling in the LightWave. Really, it's much more like a general guide to rendering and so forth, due to the topics that we're going to be covering. And also to aid us in our explanation of the new unified sampling system in LightWave 11, we're going to be looking at what has changed from LightWave 10.1 and earlier versions going way back. As a result, this sort of becomes a bit of a tutorial for doing all of this stuff in earlier versions of LightWave as well. So a little bit here for everyone, hopefully, even if you don't have the new unified sampling system. So basically what it's all about is these things, samples. When you render, your camera is just taking samples of the scene, and it takes a certain number for every single pixel. So in this case my camera's set to 2000 odd by 1100 odd, which is just over 2 million pixels, so I'll get 2 million samples taken in this scene when I'm only using one sample, because it is of course one sample per pixel or so, many samples per pixel. Now the samples pop up in three different places in LightWave. You have shading samples, which is the number of samples taken per pixel for each area where there's a shader applied, you know, a material shader or reflection shader, diffuse shader, whatever. And light samples, which is the number of samples taken per pixel for each light. You then have what we already saw here, which is the anti-aliasing samples, which is the camera samples per pixel. So for starters, we're going to leave these guys at 1 and not worry about them, whilst we just go on and take a look at the anti-aliasing samples in our camera. So here I have my scene with one sample per pixel, so LightWave's going to go along and pick out sample after sample after sample for each pixel. Only one, and this is the render that we get. Pretty noisy, and overall low quality, because we have here only one sample being taken for every single pixel. The reason it comes out noisy is because each pixel represents a certain area of space here in 3D, and there may be lots of small finite details going on in this area, from texture maps, bump maps, soft graduated shadows from lights, and so on. When only taking one sample per pixel, then only one tiny finite area is actually sampled, and that's the colour that gets delivered. And so as the ray tracer picks over, you know, minor micro shadows from bumps and so on and so forth, the result we get isn't a perfectly smooth representation of the shading. So that's all pretty simple and straightforward. So before we go too much further, I just want to explain these couple of little things here: reconstruction filter and sampling pattern. Now the first thing I'll talk about is sampling pattern. When LightWave picks these samples for each pixel, of course each pixel represents an area in space. So of course if we zoom in on our picture, then the sample has to be taken from somewhere within this pixel area. Could be taken from over here, etc, etc. What the sampling pattern does is it dirties that up, of course, so as with each extra sample it gets placed in a different spot. If it didn't, and the exact same spot was sampled repeatedly, then it wouldn't matter how many samples you used, you'd still get this same noisy image. So even when we're just using one sample, this sampling pattern is important. This guy here has been rendered using the classic sampling pattern, and there it is. Now if we switch over to another image, this is done with the fixed sampling pattern. We can see that we're getting changes here in the skin. The sample pattern is clearly shifting, but this bikini here is seemingly untouched. Mainly that's to do with the surface shader that's being used and how the classic sampling pattern is adapting itself to the different types of surface. If we look at blue noise, which is this render here, we can see quite a marked difference in all surfaces. If we look here at the edge of the shoulder, we see it with classic. We see that I'm getting these little dark pixels popping out every here and there along the edge. Blue noise, I'm getting a lot less of it. This looks a little smoother to me. So for the randomness of this skin and the edge shaping, it works out really well. However, if we look at the bikini, now this has a very fine bump on it of straight lines to create a fabric woven type of effect. And so of course that's getting moire banding here. This is the blue noise render. If we look at the classic, the pattern is different and the overall result is smoother. There's seemingly less noise in it. If we look here in these fine little lines that you can just see picking out there, classic with blue noise, not quite so well detailed. Now the difference between these sampling patterns becomes more important when we actually start increasing the number of samples used. For instance, here is a 3 sample render using the fixed sampling pattern. You can see everything's cleaning up nicely. Now what the fixed sampling pattern means is that the pattern is fixed from one pass to the next, but not fixed in where on the pixel the sample is taken from, where in space the sample is taken from, relative to the pixel, but where it is for each pixel. So as it shifts around from one pass to the next, sampling different little areas of geometry in space, all of the pixels shift around the same way. This gives very predictable results in your anti-aliasing, and it's very good if you need to get pixel perfect matches for rendered layers and alphas and so on and so forth. It's therefore very well suited to when you're doing hard-edged motion graphic style stuff, whether it's more 2D looking or 3D looking. The fixed sampling pattern can be very good for that. If we look here at the blue noise with 3, we can see some very interesting differences. We see here that the moire pattern is far, far worse using blue noise, even with 3 passes. It's much cleaner using fixed. Again, this is because of the fine little detail that's in this, and so fixed is picking that up more accurately because each sample is resampling in a uniform way to all of the other samples. Blue noise doesn't, it shifts around so it can create artifacts. But let's take a look at the arm up here. What we find on the fixed sampling pattern is we get these little dark pixels coming in which seem to create these little spikes of lighter pixels along our edges, and we can see that the stepping distance between each of these steps isn't quite uniform, it's quite random. But the blue noise render, the stepping is more uniform and the graduation is better. We're not getting these little bright spikes, so our edge detail has come out better. The point of this is that the number of samples is important, but so is the pattern in which they're used. And it will depend on the type of surface and type of render and the type of detail that you're attempting to render, which one you want to use. For instance, with this bikini, if I was using blue noise, I'd end up going quite high on my samples to get a good quality from it, so as I was getting finite, micro enough placement of samples to be able to determine the properly rendered effect without the moire. And that would of course be costing me render time. The point I'm making here is optimization, which is what controlling your samples is all about. And before you start throwing more samples at a render, it's most advantageous to start with the way that you're going to apply the pattern of those samples. Often I'll just stick to classic because it's pretty good. It sort of mixes the features of blue noise and fixed together. So in complex shaders like the skin, you get more of a blue noise behaviour, but in accurate areas like the stripes on the bikini bump, you get a more fixed style behaviour. So if in doubt, stick to classic. Reconstruction filter, basically if you're taking multiple samples per pixel, it's just how you add them all up to determine what the final pixel colour should be. As a general rule, I've found if I want nice pin-sharp renders that have, good, really clean, sharp edges, I tend to go for Mitchell Sharp. With shaders like the skin here that, are noisy and need to be smoothed out with soft shadows and so forth, that can make the noise a little bit trickier to push away. In situations like that, Gaussian is an excellent choice. Or again, classic is often good. Okay, so now that we've got all of that covered, let's start talking about sampling itself. To get all of this down, we'll start in LightWave 10.1, which of course uses the same sort of setup and settings that have been going in LightWave since like version 6. So if you're on earlier versions of LightWave, then this will help you to understand those, but of course it also goes to help us understand what's changed in 11. So we've got some shapes here, and I've got a couple of things with some nodal materials on. For instance here, this blobby shape is using the 10.1 skin node. If we open up its settings, we can see that we have a samples setting for it here, scattering samples, which is 8. And if we go to the advanced tab, there's also a sample setting for the reflection blur. So the shader contains 2 properties that have different sample settings, scattering and reflectance. And these can of course be set differently. I've also got the box, which is using conductor here, And once again, having reflectance with blurring, then that has a sample setting there. Now if we look at the lights as well, because of course lights always had a quality setting, in this scene, if I just come out here, you'll see I'm using a single dome light, and that's it, that's the only thing I've got in the scene here. And it has a quality setting here 4. This is also sampling. This could just as easily read samples as it does quality. Now in versions of LightWave going up to 10.1, the values that you entered into any of these areas were all root values, as in square roots, meaning that the actual number of samples that got used was this value times itself. So light quality 4 meant 16 samples per pixel. What's important probably, or well, maybe not so important, but handy to understand about lighting samples, is that it's not really the light that is sampled, it's the shadow of the light, which is why you only get quality or sampling settings on lights for things like dome lights, area lights, and similar. Spotlights, distant lights, they have no sample settings because they just have, perfect sharp shadows. With the exception, of course, of shadow maps on spotlights, but those aren't sampled in the same way. Those are pixel-based shadow maps, still, of course, carrying just the one sample per pixel in their shadow. I'm also going to check out my camera settings here because I have my anti-aliasing, of course, which is, as I said before, you can think of as camera samples. And for this, I'm just going to sort of put it at, let's say, 3, shall we? There we go. And we'll just do a little render. There we go, took about 30 seconds, 28.9 to render, and well, as we can see, it's pretty noisy. You see the shadows here, the soft shading from that dome light's pretty noisy. Some of the surfaces here are pretty noisy. That's mostly the actual shadow, I must point out. And of course the blurred reflection here on the conductor cube, that's also pretty darn noisy. Now, of course, as we already discussed, the way to get round that is just to throw more samples out into the scene to clean it all up. So let's give that a go. I'm going to just adjust these samples on the conductor node here. I'm going to leave skin alone. So that's currently at 8, which is of course squares. 8/8 of course being 64, so I'm actually getting 64 samples per pixel. I've then got 3 anti-aliasing passes, so it's 64 samples times 3. That's 192 samples for each pixel of the reflection. Keep that in mind, that will come in useful a little later on. Anyhow, let's bump this guy up, so I'm going to say 32 there. So that's giving me 1024 samples per pixel on the reflection, times 3 over 3000 samples. You see already our sample number is getting quite high, the actual number of samples that are going into the scene here. So let's render it. Okay, there we go. We've only gone up to 37 seconds here, so we've added just under 10 seconds to our render time. And as we can see, the reflections in the cube have cleaned up some, but they're still not that great. It's still kind of noisy, but it is significantly better than it previously was. But of course you'll notice that our shadows are just as noisy. So what we're going to do is going to take our light here. I'm going to pump up its samples. This time I'm going to go for 16. 16 16s, of course, 256 samples per shadow pixel. We can see now our render progressing here. It's chewing through it much more slowly. Okay, so here we are. We've gone up to 3 minutes and 11 seconds, so our render time has increased quite a lot. And what we can see is, yes, our shadows are significantly better, but of course the reflectance is still not perfect. We're getting basically the same amount of noise in the reflection as we did previously, because I haven't gone up and increased those samples. And of course you can see the reflectance or the reflection on the skin material here, which I haven't touched. That's still at its default of 8. That's no better than it was. The reason it's gone up to 3 minutes, of course, from the 30 odd seconds or whatever it was just previously, is because of course this soft shadow that's taking 256 samples per pixel is also being reflected in these reflective items, sorry. So of course this one, the conductor node, that's 1000 samples per pixel of reflection, but it's reflecting 256 shadow samples. So we've got 1000 times 256 going on in this area here, times the 3 anti-aliasing passes. We're getting a lot of samples thrown out into our scene now. The other problem that we're getting here with our anti-aliasing, of course, our lighting and shading samples multiplied by our anti-aliasing or camera samples is the total number of samples going out into our scene. But we see that we've got, great big areas here that are very clean, and they were clean in the lowest sample setting render, you see, but they're still getting extra sampling, which is a bit unnecessary. So here's one of the good old tricks of rendering in LightWave, which is the adaptive sampling that we have. What adaptive sampling will do, and has always done, is it will look at the difference in brightness, the difference in value between neighbouring pixels, basically to spot noise and to spot small errors and artifacts like that. And as such, the adaptive sampling lets you use samples only in the areas where they're needed. So what I'm going to do is I'm going to set this to 0.05, which is the same as 5% effectively. You see, if I use my picker here in the render, I can see the difference that exists between the RGB values, percentile values there. So that's basically what the adaptive sampling is looking at. So I'm going to hit render again. Now here we are coming to the end of this first pass of the render here before the AS kicks in, and we see that that's going to take the exact same time as it did before, because essentially this first pass that is running is the render that we just did a minute ago that took 3 minutes and 11 seconds to complete, and so this will now finish off at 3 minutes 11 seconds producing this render that we already have, but then the adaptive sampling will kick in and it will start selecting pixels that are still noisy or pixely, blocky, edgy, as we can see it doing now. You see it's selecting noise, it's all lighting up white, and there we go. So it's giving us a little extra kick. There we go, it's only added another 20 seconds, but it should have provided a little bit of cleanup for us, which it has indeed. I'm just going to have to blow this up so as you can see it a bit more clearly. Oh dear, where have I gone? Here we are. Okay, so if we see, that's our 3 minute 11 second render there. We can see the edge of the scattering shape here. We can see the noise in the cube. Let me get a bit of the ground shadow in there. So if I switch back to our new render, look at that, that's cleaner here, this edge here between the ball and the reflective cube, that's cleaner, and we can see that the noise, whilst it's still present in the cube here, it is smaller, the patches of noise are smaller and cleaner. And it's only added a few seconds to our render. To do that by just increasing light and shading samples, we'd probably have ended up adding another minute, because of course we'd have been sampling every single pixel in the image. So we're going to try something that might seem counterintuitive. I'm going to bring up my conductor node again, and I'm going to reduce samples to 1. Pretty low. Obviously 1 squared is 1, so I am getting actually 1 sample there per pixel. I'm going to do the same in my subsurface scattering thing here for both the scattering and reflection on the skin node, and I'm going to go back to my light properties and I'm going to bring your quality down to 1. So everything's got 1 sample there, and I'm going to give it 1 camera sample or 1 AA pass. I'm just going to disable adaptive sampling for a brief second and we'll just hit render, and oh my god, it renders incredibly quickly, but look at how noisy and awful that is. So what we're going to do is we're going to use the adaptive sampling to clean it up. Let's just try it as I had it there at 5%, 0.05. Very noisy first pass, and then the adaptive sampling, as we can see, starts to kick in. Okay, there we go. How much was that? 26.4 seconds. Still kind of noisy, but a huge improvement over that. So let's lower our adaptive sampling threshold. I'm going to bring it right the way down to 1% here, and we'll render again. As we can see is happening here, because I've lowered the threshold, as we go through more and more and more adaptive sampling passes, it keeps picking up large areas of the render, which are of course still noisy, and continues to clean them up. What you may also notice, if you try this sort of thing for yourself, is that whilst as you go through adaptive sampling passes, fewer and fewer pixels get flagged for additional sampling with each pass. The rendering line by line of each pass actually gets slower and slower and slower on each pass. The reason for that is because in LightWave up until 10.1, each adaptive sampling pass that is taken doubles the number of samples going out into the scene. So if you've ever tried rendering where you have, you increase your light quality a bit and you put up your AA and then you turn on adaptive sampling, you can wind up with incredibly high render times, and often it's seen confusing why. And that's the reason why, because the samples are doubling up. So if you've got 16 samples on a light, or 16 quality on a light, which gets squared, and you've got 8 quality on reflection, which gets squared, plus you've got 2 anti-aliasing and adaptive sampling, you can wind up getting LightWave to throw tens or even hundreds of thousands of samples out into the scene to try and clean up noise, and that can end up wasting a lot of time. However, the adaptive sampling is very useful if you've ever had one of those renders where you're trying to get soft shadows, or where you've got very fine, micro bump detail on a surface and you render an animation. Of course, you get flickering, shimmering pixels going on. By using the adaptive sampling, you can basically just blast the whole thing with AS to clean up the noise between pixels, to smooth out the variation between each pixel and its neighbour. And so by doing that, you could use lower settings and get smooth renders that don't flicker during animation. Whilst I'm waffling, this is completed 3 minutes 53, and look at what we've got. That's pretty smooth. We can see we've still got a little bit of noise coming here in the actual shadows from the light. But look at our cube, that's much cleaner. Look at the edges here, much cleaner. And that was only 3 minutes and some odd seconds. If we go back to, I think it was, is it this one? Yes, this is the one that had the initial, yes, this is the one that had the initial adaptive sampling that took us to just under 4 minutes. Shadow's a bit better, but the reflection in the cube is clearly worse. We can see little reflection artifacts here under our subsurface material, but if we look at the most recent one, which is comparable time-wise, we've got much cleaner reflections, slightly noisier shadows, but these edges are far better. And this is with one anti-aliasing sample, one sample per subsurface shading, one sample per shadow, and one sample per reflection. So by using our adaptive sampling cleverly, even with a lower number of initial samples, we've been able to get a much cleaner overall render in more or less the same time. So now let's check it out in LightWave 11 and see what we get here. I'll pop open my render globals. I'm just going to check that we're running at one sample. I've got 2 here, so I'm going to go 2, 1, 1, come to my camera here, 1. Okay, we're not using adaptive sampling at the minute, so we should pretty much get, that very noisy render that we saw before. There we go, in more or less the same amount of time. So what I'm going to do is I'm going to turn on adaptive sampling. I'm going to set it to what we just had there, which was 1% in that last render that we just did, and we'll F9 it again. Now what you'll see is, funnily enough, I've got exactly the same result here with adaptive sampling on. Why is that? It's because when you activate adaptive sampling now in LightWave 11, you get a maximum sample number become available. As I said before, in previous versions of LightWave, the adaptive sampling would double the number of samples per pixel with each pass, which means you can wind up going into tens and hundreds of thousands of pixels, and samples rather, and there was no way of telling LightWave to stop LightWave, you've done enough. But now we can. So I can set this to a maximum number of samples. Let's try 64, shall we? We can see that the AS is blasting away here, picking up an awful lot of noise. But of course each pass is going incredibly quickly. The reason each pass is going very quickly is because it's not doubling the number of samples on each anti-aliasing pass. It is adding 1 extra sample per pass. So I've got my minimum set to 1 sample, my maximum set to 64. So on pass 1, it takes 1 sample. On pass 2, it takes 2. On pass 3, it takes 3. On pass 4, and so on and so on and so on. You get the idea. And here we are, just coming to the end there. And we can see we've taken just under 2 minutes. and if I look close up, well, I mean, our quality of render there is just about the same as we had with the 3 odd, almost 4 minute render in LightWave 10.1. So basically we're getting a comparable quality in a bit less time. Actually, this is probably closer to the 3 minute render, to be honest with you. But that's good. I've shaved about a third off of my render time for an equal level of quality. But of course that's still a little bit noisy, that shadow's still a little bit noisy, so what I'm going to do is I'm just going to increase my number of maximum samples. As we saw in LightWave 10.1, even though you've got your quality at 4 and the samples in your material shader at 8, the number of samples used actually gets very, very high in the scene. So setting your maximum samples when using adaptive sampling, it may not be uncommon at all to use values like, let's say, 2000. Push F9. This will give us a maximum of 2000 adaptive sampling passes, or a maximum of 2000 samples per pixel, if you prefer. The two terms basically mean the same thing. Now, you'll also notice here the frame time remaining, 59 minutes. You know, I'm almost a minute into this render already and I'm 1% complete. When using this method of rendering in LightWave 11, you can pretty much ignore the frame time remaining. It's like when you're trying to copy a file of a few gigabytes in Windows sometimes, and it goes, you know, time remaining 24 minutes, 2 minutes, 1 hour, 8 minutes. Please, just tell me, haven't got a clue, because that's the real truth. This frame time remaining that it is telling me is based on the idea that every single pixel will be sampled 2000 times. It won't. Once the sampling threshold has been reached for any neighbouring pixels, they will no longer be sampled. You can see here the blank spots that are appearing in the AS pass. So as each AS pass goes through, the total number of pixels that are getting extra samples added gets fewer and fewer and fewer. But of course the frame time remaining cannot predict how many pixels are going to be finished and made okay at the end of each pass, so it can't possibly calculate an accurate figure. So do not let this dishearten you. It's not uncommon if you've got something like a character with skin on there and, you know, textures or various things going on in the scene, a number of lights, to hit F9 and it comes up frame time remaining, 8 hours, and you think, oh no, that's just never going to work, and then of course the render ends up completing in 10 minutes or something. And there we go. As we see, in the end it's taken 4 minutes to complete, so I've gone from 64 maximum samples to 2000 maximum samples, and it's only just doubled the render time basically. And if we have a good look, it's pretty nice. Noise in our reflection on the cube there is pretty good, as we can see, and the soft shadows aren't bad at all either. Now, to make this better, I could just keep increasing the number of maximum samples. I could lower the threshold, or I could chuck in a number here on oversample. What oversample does is basically just tell LightWave to add additional samples on top of what it's picked up when using the adaptive threshold. Entering a value of 1 here would give you a complete resampling. It would be no different than turning adaptive sampling off and just bumping up your minimum samples to get, however many 100 or 1,000 complete passes of AA. So you would normally use a value here like, 0.1, 0.05, 0.3, etc. But whilst doing that, bumping up my maximum samples, lowering my threshold, will of course help me to clean things up more. It will take more time to render, and what I really want to do with my renders is I want to optimize them so as I get the best balance of image quality and render time. So what I'm going to do instead is I'm going to leave all of these settings alone. I'm going to come over to my unified sampling settings here, and I'm going to turn my light and shade samples to 2, which is very nice. So that's 2 samples per pixel, plus of course all of the additional samples that will be kicked out by the adaptive sampling. Let's see what that gives us. So here it is, midway through, we can see it rattling away there. You see that the AS is picking out the edges on the cube here, and it's picking out where the actual soft shadows are. Each adaptive sampling pass is taking twice as long as it did before, because of course I've increased the number of base samples to 2 for lights and shaders, so of course each adaptive sampling pass is now adding 2 samples per pass, but still only up to a maximum of 2000 in total per pixel. And look at it, here it goes, doing its final little bits and pieces, and bingo, 4 minutes 4 seconds, so only very slightly longer than the last render. Again, let's take a good close-up look at this fella. And if we compare it to the previous one, oh, look at that. That was 359, noisy, little bit noisy, little bit noisy. Come to this one, much smoother, and it's only cost me an additional 5 seconds. And I've done that by, rather than fiddling round more here, by fiddling round here with my unified sampling. The point of this is it gives you a way to optimize your render quite easily and accessibly, and it's easy to understand. Previously, as we saw in 10.1 and earlier versions of LightWave, you had shading samples on every kind of shader, and of course for the different properties of the different shader, you had light quality for every light in the scene to adjust, and you could fanny around for hours going back and forth between changing samples here, quality settings there, AA settings, adaptive sampling settings, trying to squeeze every last second out of your render while still maintaining optimum quality. Awful lot of messing around, and it gets awfully confusing trying to remember which samples are where, how does this multiply with that, and oh my god. This is a far, far easier system to get along with, to understand, and ultimately to get the best optimizations out of. And so I'll just show you very quickly just how easy it is to understand and how these samples really do equate to one another. I'm going to turn off my adaptive sampling here. I'm going to leave my AA at 1, and I'm going to put my light and shade samples here at 256 each. Okay, and we're going to render. As we can see, it's, chewing through. It's only doing one AA sample, but it is still giving me 256 samples per pixel for reflection, for subsurface scattering, for soft shadows, and everything. Of course, since adaptive sampling is off, our frame time remaining is pretty much an accurate representation of how long it actually is going to take. Still not perfect, as you can see, because of course LightWave can't judge how long it's going to take to render these blank pixels until it has started rendering some of them, but it does give you a much more accurate idea. So here we go, just about done, and bingo, there we have it, 4.5 minutes. Let's compare that with previous. Yeah, we're not bad in terms of, shading, reflection, shadow quality here. We're about the same as we were before, possibly slightly better on the shadow there, but what we notice of course is jaggies on the edges of the ball there, on the edges of the cube, jaggy, because of course we've only got light and shade samples high, we're only using one AA sample, so that produces jaggies for us, even though we've got much smoother shading in our reflections, our shadows and so forth. But we can invert this if we like, so we can say one sample, 256 AA, push render. So here we go again, just coming to the end of this render, and bingo, there we go. So just under 7 minutes, or a little longer in terms of time. But if we have a good close-up look, obviously no jaggies because we've got tons of AA samples in there. But the actual light and shade quality is more or less the same. There's very little difference in the actual shading of these reflections, shadows, and so on. So the samples that we use here and the samples that we use there are sort of interchangeable in a way, but of course can be balanced against one another. If I leave these at 1:1, we'll see that if I go back to camera here, I don't need 256 AA samples to get smooth edges. I probably only need about 4. Okay, there we go, very quick render there, 7 seconds, obviously noisy as hell because we've got very few light and shade samples, but we can see that our actual edges of things, easiest to see here on the cube, that's quite smooth. So if I've got that set to 4, if we're going to stick with this 256 number, then of course what I want is 64, 64. Why do I want to do that again? Because it's about balancing your samples across your entire scene. To paraphrase a good old favourite movie of mine, we shall restate our assumptions. Our rendered pixels are made of samples. If we add up the number of light and shade samples and multiply them by our camera samples, patterns emerge that represent our quality. Therefore, we can determine quality through sampling numbers. 1257, push F9. And here we go, nearing completion. Once again, we're hitting just around the 4-minute mark, ever so slightly over it. There we are, 422. And let's look at what we got. Nice clean edges, reflections, pretty good shadows, and the decent render time cutting in at 4 minutes here. So by trading off our camera samples against our light and shade samples, we are able to optimize our render. And of course, let's not forget what we saw before, our adaptive sampling. I could throw that into the mix. I could say 1, 1, 1, turn on adaptive sampling and say, hey, 256, right? It's looking at a 1% difference. I'm going to make that a little bit more sensitive, make it 0.005, so that's 0.5%. So once again, we've used a low initial sample number, and we're just using adaptive sampling to pick out areas that need extra sampling, and only those areas, and telling it to use up to 256 as a maximum number. Of course, that's the maximum number that we had already in those past couple of little tests there. And there we go, there's our render. Because I have made adaptive sampling so very sensitive here at 0.005, then it has taken our render time up again to 7 minutes. But what we can see is that our render is pretty damn smooth. Shadows, reflections, really good, and of course much, much better than our previous 7-minute render, which was this one, 6 minutes 55 rather. If we compare that to this one, this is far nicer. Look at these edges and the shading quality there, much improved. Our blurred reflection on the cube here is gorgeous, smooth as silk, really nice. Changing my camera here, and of course looking at depth of field, because of course shading and shadows and reflections aren't the only place where we get noise. When we're using lens effects like motion blur and depth of field, those also generate noise, and we can use the adaptive sampling to clean those up too. So if I just kill that for a minute and we do a quick F9, in fact, just for the sake of speed and demonstration, I'm going to kill off the material shaders, so we really are only going to see the depth of field noise that we get. And there we go, we can see the edges of the cube and the shape there that are out of focus. This produces noise in our render, and we can clean that up, of course, by using the good old adaptive sampling. I'm going to set back to 1% here. And there we go, we see the adaptive sampling cleaning up the edges of the DOF noise. And bingo, what's that, 2 minutes, and we've got lovely smooth DOF going on in there. Okay, it's not particularly extreme depth of field, I confess, just in this very simple example. The objects are very close together, but you can see that it does work really, really well. But there's also other places it can come in useful, such as radiosity. Of course, trying to use interpolated radiosity, especially if we're doing animated shots, can give us flickery, splotchy stuff, and so sometimes you just want to use, good old brute force. But the problem with that, of course, is, the number of rays that you need to get a clean render is really high, and render times are just enormous. But you can, of course, by using the adaptive sampling and your maximum ray cutoff, your maximum sample cutoff, you can clean stuff up there like that as well. So I'm going to, let's just for the sake of quickness, say 3 indirect bounces here, and I'm going to use a measly 8 rays per valuation. And there we go, it's a nice accurate brute force render that's been done in only 7 seconds for a single pass, but it's noisy as hell. So I'm going to come back to my good old adaptive sampling. I'm going to push this up to 4096 actually, with a 1% threshold difference, and I'm going to hit F9. And so you see, we start to get a similar sort of effect as we were doing before with our shadows and materials. We start out with a really noisy first pass, which the adaptive sampling then flags based on the threshold values to clean and clean and clean and clean. As we can start to see already, just jumping back in here, the actual number of passes, that is, out of the 4096 possible maximum, we're only 1% of the way in, and we can see how much cleaner it's starting to look already. But with a nice low threshold value here, the AS is going to keep on picking up samples in lots of these areas and keep refining and refining and refining even further. Anyhow, whilst the whole pause edit thing is nice for you, you know, I'm having to sit here wait for these renders, and to be honest, I can't really be bothered, at least not this time. I just want to draw your attention to one last thing, and that is the kind of numbers I've been using. You notice I've been using numbers like 64, 256, 4096 and so on for my sample settings, either here or of course in the camera settings themselves. One of the things that is useful and important is to try and stick to numbers that are powers of 2, standard computering number powers of 2, so 1, 2, 4, 8, 16, 32, 64, 128, 256, yada 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 yada. You can of course just enter any arbitrary integer into these fields as you like, but that's not always a good idea to do. In fact, the majority of the time it's probably a bad idea. This is down to the way that computers interpret information, which is incredibly complex, but I'll just give you a simple little example over here in Photoshop. I'm going to make a new image, okay? I'm just going to make it 1000 by 1000 pixels, okay? I'm just going to change my colours here. And I'm going to use the render clouds filter, okay, which is basically like a procedural, as you would get in LightWave. I'm now going to use offset, which allows me to shift the whole image, basically wrap it. I'm just going to shift it by 500 each way. And you see, of course, that we get this seam. I've wrapped the image horizontally and vertically, but you see we've got a seam that's quite noticeable and visible here. If I create another new image, this time I'm going to make it 1024 by 1024, okay, do exactly the same thing, filter, render clouds, bingo, filter, offset, see what it comes out? Seamless, because the procedural generated in Photoshop is generated on these power of 2 numbers, pixel by pixel, and that gives me a seamless wrap. Now that's a different thing to what's going on in LightWave, and of course we're not talking about procedural textures, we're talking about samples that are taking place within the render, but the same basic principle does apply. So if you start using, you know, like 3 samples here, like 11 samples there, you might find that you start to get small artifacts where you don't get as clean as you should. For the best results, stick to good old-fashioned power of 2 numbers, 64, 128, you know, 2048, so on and so on and so on, and that will give you the best overall outcome. So there we are. That basically completes this guide for you on rendering, anti-aliasing, sampling, and of course the new unified sampling in LightWave 11. So I hope that's explained a lot of things for you, both users of LightWave 11 and users of older versions of LightWave 2. So thanks very much for watching, and ta-ta for now.